Hello everyone. In this video we're going to be continuing our study of kinematics, motion in one dimension, and we're still focusing on objects in free fall. And in this example, Bobby J went on a vacation to the island of Eleuthera, and he's going to help us with this video. So let's get to it. Bobby J drops a rock from atop the glass window bridge in Eleuthera. He hears the sound of it striking the ocean 1.15 seconds later. How high is the glass window bridge? Now, just for information purposes, the glass window bridge is a bridge on the island of Eleuthera inside the Bahamas, and it is a breathtaking experience because, well, this is a fact that may not stand out, but at that point, that is actually the narrowest point on the island. And furthermore, it's so beautiful because on one end, you have the Atlantic Ocean, which can be a very, very intimidating dark blue. And on the other end, you have the Bight of Eleuthera, which is so beautiful. You see the beautiful waters that the Bahamas is actually known for, and the contrast, seeing it as a natural thing is breathtaking. And I'm actually really jealous of Bobby J. Nonetheless, let's get back to the physics at hand. So let's write down some things that we know. Bobby J is on a bridge, and let's just assume that he drops the rock with zero velocity. So velocity in the y is 0 initially, and this rock is under free fall because there's no other force acting on it other than gravity. So gravity is 9.8 meters per second squared. Now, that doesn't help us much because it's really all we know. Now, we could go through a few things and we could figure this out with a bit of substitution and etc. However, I want to point to a different way. We know that he hears the sound of the rock striking the ocean 0.15 seconds later. Okay, let's pay close attention as I'll actually write that down. 0.15 seconds later. Okay? Now, this is the speed of sound. Let's assume some ideal atmospheric conditions, okay? Such that the speed of sound is 340 meters per second, okay? Now, our kinematics equations bring us into issues because of several things. We don't know the time it takes to fall, nor, actually we want to find the height. We don't know the time it takes to fall, and the only information we have is gravity, and we have the initial velocity is 0. And that really doesn't tell us much. However, this part right here, this is significant because 0.15 seconds after the rock strikes the ocean, that sound has to travel from wherever the ocean is all the way up to Bobby J in order for him to hear that. So that we could assume that that sound travels that straight distance up. Actually, the sound does travel that straight distance up. So we could find the distance that the sound traveled, and we know that the speed of sound is constant. And we know what that speed of sound is. So seeing that we know what the speed of sound is, and we know the time it takes for that sound to travel from the ocean all the way up to Bobby J, we could find the distance that that sound traveled. And that distance that the sound traveled, we can even visualize it right here. The sound has to travel from this point all the way up to here, and it just so happens that that is the exact distance that we want. So if you don't remember the equation, it's always good to start with basics. We know velocity is equal, or speed. Speed is equal to distance over time. So with a bit of transposition, this arrow just means implies. We know that x is equal to velocity times time. So that distance is equal to 340 times 0.15 seconds, and 340 times 0.15 is actually 51 meters. So the glass window bridge is about 51 meters high. Now, how accurate that is, I cannot verify, but that's my ballpark figure. And in this example, I just wanted to show you how sometimes you don't always have to rely on the equations that you're given. Sometimes you're given a question in a particular topic just to see if you're thinking, because there's some cases where you would bang your head against this saying none of these equations work. Oh my goodness, what am I going to do? And that's where your physical intuition comes in, and that's where your knowledge of sound would come in, because we know, well, if you would have encountered it before, and if you haven't, I'll explain it to you. I'll give you a fundamental or rudimentary explanation of it, at least, that the speed of sound is constant, and it can change based on atmospheric conditions, but we're going to assume ideal atmospheric conditions such that the speed of sound is 340 meters per second, and this speed is constant, okay? And we know that it takes 0.15 seconds to travel from where it was to Bobby J, and we're going to assume that height is the height of the cliff, or it's very, very close to the height of the cliff. And that information can really, really help us. So using that knowledge, we were able to deduce that, okay, the distance that the sound travel must be the same or very, very close to the height of the glass window bridge, which is what we did here. And to be honest, the only way that you begin to build this intuition is by doing problems. And you don't always have to get the right answer, but it's actually the process of solving the problem and learning how to think and learning how to make these connections that really helps build up your physical intuition. So to close, I just want to tell you congratulations, because again, physics, to some persons, it's a completely different beast. So watching this video, I hope it really helps you. Just the fact that you took the time to sit through this, you are amazing, and I just want you to stay encouraged and continue practicing, continue studying, and continue asking questions. And I hope your curiosity continues to grow, and I'll see you next time.